Now that you have been introduced to the seminar and understand some of the science behind double stars, you are ready to plan your research project. The first and most important thing you need to do is scope your project. With a clear end goal in mind and attention paid to resource and schedule constraints, you will be able to pick a project that is within your scope. Next, you should organize your research team. By knowing the talents and interests of your team members, you can plan a project that will fit the team. You may later on draw on resources outside of the class by signing up experts and others to give you a hand. Some may become full team members. Then, select your project. Projects are observational. They can be observations of one of various types of double stars and may use one of several different observational techniques. The observations may be original or may draw from recent unpublished observations. Develop your research project plan. Put your project plan in writing. Keep it brief. Next, refine, negotiate, and submit your proposal. Finally, informally run your nearly final proposal by the course instructor before formally submitting your proposal. Refine your proposal and negotiate major changes. After a final English grammar check, submit your proposal with confidence. It is vital that you scope your project. Have a clear end goal. Projects often flounder because the end goal is not clear. Your end goal should be to successfully finish this course by completing a double-star research project that will contribute to scientific knowledge and, in the process, also increase your knowledge of how scientific research is conducted. Keep in mind that you have 3 specific deliverables that are due at specific times that need to meet stated requirements. The 3 deliverables are a research proposal, a paper submitted for publication, and a public presentation describing your research. There are also some intermediate deliverables in terms of drafts of your team paper. Essentially, all research projects are conducted under constraints. Since your project needs to be completed in less than a semester, you will be operating under a very tight schedule constraint. The first part of the semester will be taken up with learning about double stars and planning your project. The last part of the seminar will be taken up with writing, reviewing, and refining your paper, and preparing for and giving a public presentation. This only leaves a few weeks to actually conduct your research. Your team members will have a limited amount of time they will be able to devote to the research project. Equipment, such as telescopes or cameras, may or may not be readily available to you. Funds for travel or other activities may be limited or unavailable. By either using pre-made but not yet used observations or using a remote robotic telescope for your observations, you can avoid most problems associated with making the observations yourself. The single biggest and most common mistake by far made by student and professional researchers is being overly ambitious. Do not expect or even hope that your first published scientific research will lead to a Nobel Prize. Choose a project that appears it could be done in much less than half of the available project time. It is always better to have extra time available to polish your project than to be scrambling at the last minute to meet a deadline. The worst thing you can do is be gathering data or doing analysis to the very end and not have time for making refinements to your write-up, taking enough time for thorough external reviews, etc. Organize your research team. The team or instructor will eventually need to choose its leader. The team leader does not need to be the most active or knowledgeable team member, often just a good spokesperson for the team or a good organizer. Usually, team leaders naturally emerge. Team leaders are usually the first author of a team paper, and as first author, they have significant responsibilities for following up on the team's paper and sometimes making sure it is finished. Thus, being the team leader entails making a serious commitment beyond the end of the seminar's official end date. The team members will have varied interests and talents. A key to research project success is matching the tasks that need to be done to the team members' interests, talents, and time. Scientific research is somewhat similar to team sports, such as football, where team members specialize in different tasks. Some team members may be good at mathematics and analysis, while others excel in writing and editing. Some team members may be at home with equipment, while others prefer software. Some team members may have more time to devote to a project than others. The research team does not need to be and should not be limited to just the students taking the seminar. Teams are not only free to obtain help from outside the course, but are strongly encouraged to do so. All is fair in love, war, and scientific research. Well, almost all. What counts is the quality and completion of the research. If the team can entice an outside-the-class double-star expert to join their team, they should go for it. If your outside team members contribute in a major way to your project, include them as co-authors in your paper. If their support is helpful but not major, be sure they should be thanked in your paper's acknowledgments and in the prelude to your presentation. From a number of possibilities, select your project type. There are a wide range of double-star observational projects, depending on the type of object being observed, the observational technique, and whether the observations need to be made or have already been made. The types of objects being observed could be known or suspected optical doubles, common proper motion pairs, or binaries. All three types of astrometric double stars are worthy of investigation. Any of the major observational techniques could be used to make the observations. These are a visual astrometric eyepiece, although not recommended, a regular CCD camera, or a high-speed camera for speckle interferometry. Making new observations provides students with an opportunity to use a telescope equipped with some instrument. This can make for an attractive project, but learning how to use telescopes and instruments is not always easy. Furthermore, the weather may not cooperate. Using previously gathered but not yet published data for a project can be very low risk, allowing students to quickly concentrate on data reduction and analysis and writing their paper. Also, the already gathered data can be from observations made on a large, high-resolution telescope with an advanced technique such as speckle interferometry. A middle ground can be obtained using new CCD observations from a remote robotic telescope. In this case, the team usually doesn't have to worry about the equipment and weather. The project will need to be broken down to discrete tasks, and each task briefly described in writing. Finally, the tasks need to be arranged in a schedule. Key milestones should be identified, including when the deliverables are due. Once the tasks are specified and the schedule has been laid out, it may become obvious that the project is too ambitious and there are insufficient working hours and scheduled time to accomplish the project at an acceptably low risk. Often the plan can be scoped down, but if not, now is the time to switch to another less optimistic project. The key to success is to refine your proposal. Once you have an acceptable, non-optimistic, conservative proposal, take the time and effort to refine your proposal. It can be helpful to have others outside of your team review your proposal. Proposals to most funding agencies, such as the National Science Foundation, are one shot in that once submitted, they are either approved or disapproved. If disapproved, one typically would have to wait until the next year before submitting a revised proposal. However, one can often get a good feel from a funding agency what their reaction will be to a proposal. Many agencies send proposals out for review by subject matter experts. There is no reason why you cannot, on your own, send a near final version of a proposal to subject matter experts yourself in advance of submission, and then use their feedback to improve your proposal. In the case of this seminar, there is no rule that says you can't ask the course instructor to look over a draft proposal prior to submission. Finally, and this is a big step for your team, you will formally submit your proposal for consideration. Don't miss the due date. Unlike proposals to many agencies, your course instructor will not reject your proposal. Rather, your proposal will either be accepted or returned for revision. Most often, if a proposal is returned for revision, it will be because the instructor knows from previous experience that your proposal is probably too ambitious and needs to be scoped down. In this seminar, failure is not an option.